Okay, in this video, I'm going to show you how to take spectra, not optical spectra, but radio spectra, using our 6-story, 150-ton radio telescope in West Virginia. So let me share my screen. Okay, here we are at Skynet, and we're going to go to my observatory, but instead of optical observing, we're going to go down to radio observing. This will take you to a page, much like on the optical side of Skynet, that lists all your current observations. Your first time here, this should be empty. So let's go over here and add a new observation. So what we're going to do is take a series of spectra, beginning here at the center of the galaxy and working our way out the galactic plane out to almost 90 degrees, which is somewhere around here. Now, the easiest way to do this is to use galactic coordinates. So come to the coordinate type and change it from right ascension declination to galactic longitude and latitude. And we'll start with 0, 0. That's the center of the galaxy. And when we come back next time, we'll increment the longitude. We'll keep the latitude at 0. That keeps us in the plane of the galaxy. But we'll keep increasing the longitude until we get to almost 90 degrees. Now you have to give it a name. You can call it whatever you want. I'll just use GL for Galactic Longitude, and then I'll put the number. And it's useful if you put the galactic longitude in the name. That way when you're searching through your observations, it will be clear which observation corresponds to which longitude. So I'll just name mine GL0, and the next one, which will be at 8 degrees longitude, I'll name that one GL8. Minimum sun separation, that can stay 0. Minimum target elevation. The galactic center is pretty low in the sky in West Virginia, so I'm going to lower this a little bit to give us more time to get that spectrum. So you should set your minimum target elevation to 15 degrees. Okay, we'll scroll on down. The visibility chart currently does not work if you're in galactic coordinates, so don't freak out if you don't see anything there. That's something we'll correct. And I'll press save and continue. Now on the optical side, you'd be taken to the page where you select your filter. And by selecting your filter, with an optical telescope, you're putting a colored piece of glass in the optical path, red, green, blue, whatever. And what that does is it filters out all the light except for that color. And each color corresponds to a different wavelength or a different frequency. Now in the radio, we don't use colored pieces of glass. This is done in the electronics, but it's basically the same idea. So that's what we're going to do on this page, is select our frequency. And the first thing you want to check is make sure that the L-band receiver is on. It's kind of like the camera, but it's a big electronic device. L-band refers to this particular frequency range, and that includes the 21 centimeter emission line that we're going to be targeting. Okay, now what we want to do is take a high resolution spectrum. So be sure to switch from low resolution mode to high resolution mode. And two frequencies should come up automatically, 1406.25 and 1421.875. Those are good. We're actually going to take two spectra, one centered around this frequency, which is of no use to us, and one centered around this frequency, which should include the 21 centimeter cold hydrogen emission line. In high resolution mode, it automatically takes two spectra. So we'll discard the first one and use this one instead. And your channel should be set to 1024, and we'll save and continue. And path type, we have different options. We can do maps and daisies, but those require a great number of credits, and it's more advanced functionality. We will just do a simple tracking, so the telescope will point to this particular location, and we'll track it for the duration of our observation, which only needs to be 1 second. It's a big telescope. It collects a lot of light, radio light, but it's still light, and 1 second is enough to get a good spectrum of the 21 centimeter emission line. Integration time, 0.3 seconds is fine. Repeat should be 0. Save and continue. And then go down here and submit it. You can see this is the one that I just collected. Now, you'll have to submit a series of these, and you could re-enter all that over and over again, but I'll show you a little trick here. Go to the one that you just submitted and press resubmit. And then it should be set up just as you left it. Galactic longitude, we're going to change that to 8 degrees. That's this number here, degrees, arc minutes, arc seconds. Or you can just erase that and use decimal format. Just type in 8 or 8.0, either is fine. Be sure to change the name to match your new galactic longitude, but everything else should be the same. Save and continue. This should all be the same. Save and continue. The same. Save and continue. And then submit. And then you'll enter the next one. And which ones you're supposed to take, which galactic longitudes, those are listed in the lab. Just enter them all, and if the galactic plane is up, you'll probably get your observations back pretty quickly. If not, they'll be acquired, the next time the galactic plane is visible from West Virginia. Okay, that's it for this video.